Hello and welcome to our YouTube channel Chemistry with Tanvi. In last lecture we studied about the classification of halogen derivatives on the basis of hydrocarbon skeleton and number of halogen atoms attached to the hydrocarbons. In today's lecture we start the classification of monohalogen compounds. So in monohalogen compounds are further classified on the basis of position of halogen atom and the type of hybridization of carbon to which the halogen atom is attached. Okay, first point is alkyl halides or the haloalkanes. In alkyl halides or the haloalkanes, the halogen atom is bonded to sp3 hybridized carbon atom, which is a part of saturated carbon skeleton. Alkyl halides may be primary, secondary or tertiary depending upon the substitution state of the carbon to which the halogen atom is attached. Here in this point, primary halides means primary halides are the compounds in which each primary, secondary and tertiary halides contain always sp3 hybridization. These are all sp3 hybridized hydrocarbons in which what is meant by primary halides. Primary halides are the compound in which this halogen atom is attached to the sp3 carbon atom, and the identification of primary halide is there is presence of one R group and two hydrogen atom. In next, secondary halide means the halogen atom attached carbon containing two R group and one hydrogen, and in tertiary halide the halogen atom attached carbon containing 3 R and there is no hydrogen. This R represents the alkyl groups. So the compounds are known as the alkyl halides or the haloalkanes. The next is allylic halide. In allylic halide, halogen atom is bonded to sp3 hybridized carbon atom next to carbon-carbon double bond. This halogen atom is attached to the sp3 hybridized carbon atom, which is next to the carbon-carbon double bond. That means, first of all, what is meant by the sp3, sp and sp2 hybridized carbon atom? There are three types of hybridization in hydrocarbons: sp3, sp2 and sp. In sp3 hybridization, there is presence of carbon-carbon single bond. In sp2 hybridization, there is presence of carbon-carbon double bond, and in sp hybridization, there is presence of carbon-carbon triple bond. So in previous alkyl halides and this allylic halides, both types, the halogen is attached to directly sp3 hybridized carbon atom, which is next attached to the carbon-carbon double bond. So such type of systems are known as the allylic halide. They are present in open chain compound or closed chain compound. Open chain and closed chain. Here this halide is directly attached to the sp3 carbon atom. Here carbon atom is there, carbon-carbon single bond, carbon-carbon single bond, and this attached to the next to the carbon-carbon double bond. So this type of system is known as allylic halide. Okay, and if this halogen is replaced by any halogen like chlorine, fluorine or bromine, then it is known as allylic chloride, allylic bromide or allylic iodide. Then next is C, that is the benzilic halide. In benzilic halide, halogen atom is bonded to the sp3 hybridized carbon atom, which is further bonded to the aromatic ring. Here in simple, what is mean by or what is the formula of benzene? That is C6H6. What is the formula of phenyl? That is C6H5. And what is the formula of benzene? That is C7H7. Okay, so here the structure is C7H7. Here also structure is C7. Okay, in this benzilic halide, halogen atom attached the carbon atom, which is sp3, directly attached to the benzene ring. And here also the hydrogen of sp3 carbon atom is replaced by two methyl groups. So here also the compound form or the structure form are known as the benzilic halide. Okay, halogen atom attached to the sp3 carbon atom, which is attached to the aromatic ring. So if here the X is bromide, then the compound name is benzilic bromide. Okay, now D, vinylic halide. It is again very simple. What type of hybridization do you see here? That is carbon-carbon double bond, so sp2 hybridized carbon atom. Then what is the definition of this vinylic halide? The halogen atom attached to the sp2 hybridized carbon atom. Such type of compounds are known as vinylic halide. Here also in closed chain, halogen atom is attached to the sp2 hybridized carbon atom. Okay, such type of functionality is known as vinylic halide. Let us see one example. CH2 double bond CH single bond Cl. What is the name of this compound? This is the vinylic part, this is halide part. So vinylic chloride. Okay, then next is haloalkene. Again, what type of hybridization do you see here? Carbon-carbon triple bond. That means it is a sp hybridized carbon atom. Okay, then the definition is when the halogen atom is attached or bonded to the sp hybridized carbon atom, then it is called as haloalkene. Okay, alkyne is a carbon-carbon triple bond hydrocarbons. So if we replace this or we add the chlorine for this hydrogen, then the compound having formula CH triple bond C Cl. Then the name of this compound is halogen part is chlorine, so chloro and here alkyne. Okay, then next is and last one from this, that is aryl halides or haloarenes. Here in aryl halides, halogen atom is directly bonded to sp2 hybridized carbon atom of an aromatic ring. You know that in benzene all carbons are sp2 hybridized. That means every carbon is containing carbon-carbon double bond. So in aryl halides, one of the hydrogen of benzene ring is replaced by single halogen, that is monohalogen, single halogen. Then such type of compound is known as aryl halides or haloarenes. If this X is chlorine, then the compound name is chlorobenzene or aryl halides. Aryl group is benzene and halide is a chlorine. Okay, Hope you understand this point, that is the classification of monohalogen derivatives. Okay, thank you for watching. If you enjoyed this video and found it helpful, please give it thumbs up, leave a comment and subscribe too. Don't forget the hit bell icon to stay updated to our latest videos. See you next time. Bye. Thank you.